We're here today for your tomorrow. We're EHC, one of the foremost suppliers of electric heating and hot water products. Based in Scotland, we operate across the UK and beyond, with a product knowledge and support unrivaled in our industry, and a product portfolio to accommodate almost any central heating and hot water requirement, designed with both the installer and the homeowner in mind. We offer a complete range of high-quality products, including electric boilers, electric radiators, unvented stainless steel cylinders, and warm air heating. From initial inquiry to completed order, you can be assured of dealing with the most experienced and committed personnel in the business, all of whom dedicate their attention to our award-winning customer care. Our products are specified in many contracts throughout the UK, with a customer base including social landlords, private landlords, developers, homeowners and the general heating trade. And all of our systems are designed to comply with the latest building regulations and domestic heating compliance guide. Safety and eco-fundamentals are always at the core of our product design. Our in-house design team provide comprehensive support to specifiers, architects, house builders and heating contractors. We will assess your requirements and provide the necessary heat loss calculations required for your project. All designs include costings, dimensions, weight and warranty information. We offer this design service for single rooms, single properties and multiple properties. We are constantly innovating, continually growing. We are EHC, here today for your tomorrow.
Good morning guys, and welcome to EHC, to one of our first electric boiler training courses via our new training academy. I'm Chris Allen, I'm the Service and Technical Manager here at the Electric Heating Company. So we'll get kicked off this morning. First we'll look at general electric boiler requirements and good practices, and then we'll go on to look at each of our boilers and a bit more in-depth features, technical aspects and also a bit of fault finding. So to start things off, electric boilers themselves, it's no different to installing these as to installing gas or oil. Hydraulically, it's all the same principles. You're doing it on standard pipework, standard radiators, and obviously when we come to the sizing of the boilers, again it's done the same, a standard heat loss. What you will find is an electric boiler kilowatt output will be much smaller than that of the gas kilowatt that's possibly in. Mostly because gas boilers are less efficient and oversized in most general properties. So for instance, the average kind of 2-bed property might be around about a 9 or a 12 kilowatt, whereas when we were doing gas boilers you'll probably have had 25 to 32 kilowatt in there. With the electric boilers, it's good practice obviously to have good filtration on the system, so we do recommend a high quality filter, a bit like an 80 Magna Clean or equivalent, and the boiler themselves should be valved, flow and return for easy purposes when it comes to servicing. When it comes to the general install, for the heating engineers out there, as I says, you're not going to see much difference. Hydraulically you're still putting the boiler on the wall, fitting your valves, fitting your filter, piping away to the system. Big difference you'll see is less work because you don't have a flue to install and you don't have a gas pipe to deal with and you don't have any of the commissioning checks required after that. However, the electrician now has a bit more because he's going to need to bring in a heavy duty power supply capable of running that boiler, and then also you've got your controls as standard. So from that, on the electrical side, depending on the boiler kilowatt will depend on the supply required. Now, the higher the output, once we got to the likes of 12 and 14 kilowatt boilers, you are looking at 16mm cable and the likes of 63 and even 80 amp supply protection. Now, that then pulls us back to the property in question as a whole, because power is limited in domestic dwellings, unlike gas, where we can fit any size of gas boiler without much consideration. Electric, we do have to consider the total current draw of that property. So from that, we need to look at what is being used in the property. electric cookers, electric showers, etc. And then look at the property supply itself. So when you are out looking at the property, sizing it, one key point is to check the main incoming supply. Now, some of these are stated on the cable head, but we don't always go with that sticker because it can be incorrect, so obviously contacting the local DNO is the best option. Now, for any boiler 10 kilowatts and above, you need 100 amps coming into that property. As we go down the chain, then 80 amps can be suitable for smaller boilers, 7, 9 kilowatt. But generally 10, 12 and 14, you will need to make sure a full 100 amps is present. Other considerations need to be taken. Electric showers, for instance, these are high load appliances in their own right, running at anything between 8 and 12 kilowatt. So where that property is, 100 amp won't even suffice for an electric boiler and an electric shower at the same time. So considerations need made there in the form of the EHC shower flow sensor. That can be connected to the boiler, connected to the shower. When the shower comes on, the boiler will automatically switch off, protecting the main incoming supply and preventing the two appliances working at the same time. The same principle can be used with other devices in the home. Pottery kilns, for instance, is one. Large range cookers, albeit you won't use the sensor, but there is a little bit of smart control wiring can be done so that if the cooker comes on, the boiler automatically switches off, protecting that main incoming supply. Otherwise, if you want to run these appliances at the same time, you will need to go for a costly upgrade and move on to 3-phase. Boilers themselves range from 4 kilowatt all the way up to 48 kilowatt. However, on single phase domestic power supplies, we go from 4 kilowatt to 14 kilowatt. After we pass the 14 kilowatt margin, we then have to go into 3-phase power because it exceeds 100 amp. So this is where it's crucial that we size the boilers correctly and make sure that we're not oversizing the boiler and utilising power that's not there. Where you do need to go into boilers that are 19, 24, 26, 39 or 48 kilowatt, as I say, is 3-phase power is required. And it is a case of contacting the local DNO and just looking into whether they can upgrade it and for what cost. So that's the main installation considerations. So obviously you do need to think more of the electrical side now, but again, don't let it put you off. Your Sparkies are there to help out with that, or we're here ourselves. Within EHC we've got a fantastic technical team where you can pick the phone up, give us a call, and you will speak to someone there and then on the phone who'll be happy to answer the question, talk you through it, whether that is sizing the boiler, installing the boiler, or get into a bit more detailed control systems for the purpose of high load appliances and demand side shedding, etc. So what we'll do is we'll start to look on at the individual boilers themselves and go through each one. If you've got any questions at any time, just use the chat function. We'll pick the questions up from that and answer them as we go. And so first of all, we're going to move on to the Comet combination unit.
Introducing the Comet Electric System Boiler from EHC. Designed primarily to eliminate unnecessary external pipework and plumbing, these cost-effective, highly efficient boilers are the ideal choice for properties which have wet central heating and underfloor heating systems. To ensure maximum efficiency, all Comet boilers incorporate 6-stage heating using a stainless steel heat exchanger. This unique facility will modulate the boiler to reduce electricity consumption and running costs. The easy-to-use control panel with LED display provides operating temperatures for flow and return, system flow rate and kilowatt output information, and enables the installer to utilise the inbuilt self-diagnostic feature during installation or routine maintenance. The temperature outputs range from 25 degrees Celsius to 65 degrees Celsius for domestic hot water and 20 degrees Celsius to 85 degrees Celsius for central heating, providing a great range of temperature outputs for any dwelling. The single-phase electric system boiler outputs are 6 kilowatt, 9 kilowatt, 12 kilowatt, with the 14.4 kilowatt available for properties that require larger outputs. All Comet boilers can be installed for heating only or heating and domestic hot water purposes when used with an S-plan configuration in conjunction with our twin-channel heat pack. As well as being 100% efficient, the Comet Boiler is virtually silent in operation, with inbuilt fault-finding diagnostics among its many features. It also comes with a 2-year guarantee, and extended warranties are available. The Comet Electric Boiler from EHC, providing homeowners with complete peace of mind and optimum performance. For more information on this boiler and boiler packs from EHC, visit electric-heatingcompany.co.uk.
Hi guys, welcome back, and hopefully you enjoyed that wee short video just introducing the Comet combination unit. So as the video explained to you, the Comet combination is our all-in-one floor standing heating and hot water in a box, to put it bluntly. So from the Comet combination unit we have a 140 litre stainless steel unvented duplex cylinder, and which will also provide your central heating as well through the heat exchanger. Now this cylinder within the unit itself is heating directly from the primary heat exchanger, which is a bank of elements. That does the work for the radiator side and also the hot water side via what would be known as a traditional S-plan, but all integrated through 2 zone valves, diverting the water off to the radiators or to the coil. Now the Comet combination unit itself comes with an Erp pump like all our boilers, and it also has built-in weather compensation, along with built-in programming for the heating and the hot water side of things. So everything is controlled from the controller on the front of the boiler. Now with the boiler we provide a room temperature sensor or a wireless thermostat. Both come as standard, and it's up to you as the installer to choose whether what option you install, whether you use just the standard room sensor, meaning that the boiler records and measures the temperature of the property, and temperature and time is both controlled from the screen of the boiler itself. If the customer doesn't want to be back and forward to the boiler to adjust temperature, that's why we also include a wireless room thermostat. So that can be wired into the boiler's control panel, and it now takes the temperature adjustment away from the boiler and moves it remotely into the property. Time control will still be done inside the boiler's program itself, but at least the room temperature can be adjusted and measured remotely. Hot water as well is set from within the programmer, and can be set for multiple different times, with different days of the week receiving different times for the heating and the hot water, so there's lots of flexibility there. The hot water side of the boiler as well also has an Anti-Legionella function, so should the homeowner decide that they want to operate the cylinder at a lower temperature, down at the 45, 50 to 55 degree mark, then we activate the Legionella function, and what that will do is once a week that will bring the cylinder all the way up to 65 degrees and hold it there for a period of time, just to stop any type of formation of Legionella. With the central heating side, as far as piping it out, all the connections are on the top of the boiler, flow and return. That can be piped out to a traditional radiator circuit, underfloor heating circuit, or a mixture of both depending on the install. Again, if we're using the weather compensation, the weather compensator will automatically control the temperature of central heating water dependent on the outside temperature, but it's not suitable for every customer. Not every customer likes weather compensation and the fact that the boiler automatically decides the temperature. So for the customer that wants 70 degrees going through their radiator all the time, or 50 degrees, the weather compensator can be deactivated and the temperature manually set in the program of the boiler. So again, a couple of features of the boiler itself. The main power comes in here at the top left side corner and loops over into a device we call WT3. This is the main high limit thermostat for the boiler, and it's common through all our boilers, as you'll see as the morning goes on. So from that, this device then allows power down into the main electronics. So we've got the power board at the bottom here, which controls the elements, and we have the main control panel up here, which has got the main brains of the boiler, along with your external inputs from weather compensation, room temperature, etc. On the front here we have the nice clear digital display panel with a two dials. Bottom dial simply puts the boiler on off and switches it between heating only or heating and hot water for summer and winter. And then the top dial itself is a case of rotate to go through the menus and then click on it to select what setting you're highlighting. Now from the display panel itself we can see exactly what the boiler's doing. We can see the tank temperature, we can see the outside temperature if the sensor's been fitted, and we can see at what point the heating's on, the hot water's on and what state the boiler's in. The other great feature is the diagnostics on it. If there is a fault with any part of the unit, you will see an error on the screen, and by clicking the top dial you will then get a list of what those errors are in a bit more plain English, for instance hot water valve error, central heating valve error, and so on, to make it a lot easier to diagnose. Coming over to the top end here, we've got the motorised valve for the central heating and the hot water one in at the rear, behind the control panel. We then drop down to our 3-bar safety discharge, which is taken down to the bottom and out either the right or the left hand side, depending on the installation. And that is terminated like any normal discharge pipe you would experience on a gas or an oil boiler. From there we come down onto the main heat exchanger, which is an automatic air vent at the top, so that we can keep the air out the cylinder, and that will then drop down into the elements themselves. Most heat exchangers have got 3 elements, which then can modulate based on the control panel. Voltage will be altered to change the output of the boiler depending on the circumstances of the installation, flow rates, differentials, etc. Moving further down, we then move on to the smart Erp pump, and below the pump we provide a drain valve for the central heating side of the boiler. We then have a digital pressure sensor, which can be viewed on the panel along with every other sensor. And coming up the side we have an inline strainer with a magnetic filter and gauze. Now this is our kind of minimum protection, last ditch protection for ourselves, but obviously we would strongly recommend that every installation has a proper filter external, again like I mentioned, the MagnaClean or any other good reputable filter, just to get as much filtration in that system and keep the contamination down. Above that is what we deem the power board. So the power board is what controls the elements and varies that voltage and output up and down to allow the boiler to modulate. So with the unit, we're an all-in-one unit, we also include the expansion vessels at the rear. So as you can see, red expansion vessel is for your primary side central heating, and then your white expansion vessel, your 3-bar, is your normal secondary vessel for your unvented cylinder. Now the Comet Combi itself is ideal for flats, 1, 2 beds, up to some 3-bed properties. Once we go above that, due to hot water requirements, you probably want to go back to a boiler cylinder setup so that we can get a bigger capacity. But as I say, the 140 litre capacity in this unit is ideal for 3-bed and below. Quick install, you lift the full unit in as one big unit, drop it into place, a bit like a fridge freezer, and then put all your pipe connections onto the top. So you've got your cold mains in, your cold balance out, your hot out, and then your flow and return out for central heating. From the left hand side of the unit here, we then have the discharge for G3, which will come out into your turn dish and then be discharged and installed as per the normal unvented regulations. So with the boiler itself, as I says, with the inbuilt diagnostics, it's very clear when things go wrong. A couple of other points to that is WT3, obviously as I say, that's a high limit thermostat, so should the main heat exchanger overheat, that's going to trip out and put all the power off to the boiler. In that case, most likely causes for that device to trip are air in the system, which is rushed back into the boiler in a large lump, reduced flow rate due to a blockage on the system or a clogged filter. Or if the property is prone to power cuts, if the boiler's running at full capacity and experiences a loss of power, due to the boiler going from full output to nothing without pump overrun, this can cause latent heat to build up and trip the device out. So it's very rare that the WT3 itself is the fault. It's usually, and should always be deemed as the symptom. Not to say that over time they don't wear out, but generally you're always looking at a different issue first. The only component inside the boiler that can really affect the WT3 in a fault state would be the power board. Should the power board fail, one of the switching triacs jams in an on position, then once the boiler does a shutdown, there's still voltage going through to an element. That would then increase the temperature and blow out the WT3. If that is the case, it's a simple check with a multimeter and a set of voltage testers. We've got 7 terminals on the power board. 1, 3 and 5 are your supply in, with 2, 4 and 6 being your switching terminals out and 7 being your neutral. So on a single phase boiler, we can test the outgoing terminals when the control panel's switched off. All of them should be dead. If they've had voltage on them, then we'd know a triac has failed and that board needs replaced, and that is why the WT3 itself has tripped out. Now, another point when it comes to trip out, etc., the cylinder side, the hot water side itself, has its own thermal cutout as well, which can be, hopefully you can see this, can be found just in behind the main wiring, and there's a little reset button there. So should the boiler be showing hot water valve error, this may mean that it's just the trip out has went due to a slight overheat, and it is a case of just resetting the button. Other than that, with the Comet Combi, it's all included in the one case, as we said. Down lower on the boiler, there is a blanking port for the purpose of fitting an immerser element, should the customer want a hot water backup, or should they want to connect it to PV and utilise that generation into their hot water cylinder. At the very bottom of the tank is another drain cock, so that we can drain the tank down easily should any maintenance work be required. With the Combi, it is set up generally for one heating zone, so if you were looking to have multiple heating zones external to the boiler, it can still be done. It's not out the box designed for it, but we can add some external control wiring and do a bit of configurations. But as I say, generally it would be designed to run just one heating zone from the main unit itself. But if you do come across a situation where you're installing it and you do need extra zones, then give us a call in, we can help you out, drop you over a couple of diagrams on how that would be achieved. But other than that, as it says, that the Comet Combi is a great ideal all-in-one unit for a quick install. And so what we'll do is we'll now move on to the next boiler, which we're going to be looking at is the Slimgen Boiler. Again, as I said, if anybody's got any questions at any point, please just use the questions tab on the platform, and we'll answer them as we go.
Introducing the Slimgen Electric Flow Boiler from EHC. The Slimgen is a fully controllable electric boiler which is designed to maximise cupboard space, making it ideal for heating applications where space is at a premium. Our single-phase electric flow boiler outputs are 4 kilowatt, 7 kilowatt, 10 kilowatt, 12 kilowatt with the 14.4 kilowatt available for properties that require larger outputs. The Slimgen boiler can be used in an S-plan configuration to enable you to select heating only, hot water only, or both at the same time. It is 100% efficient, virtually silent in operation, and easy to install. The Slimgen electric flow boiler also has an easy-fit front cover for future maintenance purposes. It has a user-friendly front control panel incorporating an easy-to-use temperature control dial, as well as heat and fault diagnostic indicators for the user and installer. The boiler temperature range can be set between 30 degrees and 80 degrees, which also makes it a suitable choice for wet central heating radiators and underfloor heating systems. Safety is of paramount importance, and as such, the boiler incorporates a unique high current safety cutout device to protect the boiler against overheating. The Slimgen can be supplied as a standalone unit, or complete with a choice of boiler packs for heating only or heating and domestic hot water installations. Each Slimgen boiler comes with a 2-year guarantee and with extended warranties available. The Slimgen Boiler from EHC. For more information on this boiler and boiler packs, visit electric-heatingcompany.co.uk.
Right, welcome back guys. So that was the quick intro to the Slimgen boiler. So now we'll look at going through it a bit further. So as you can see, here it is just to the side of me. So Slimgen Boiler, which is referred to as a flow boiler, just due to its simplicity. Returning at the bottom, flow out at the top. There's no mechanical parts in between. It's a case of the water is straight in through the heat exchanger and back out. Now, Slimgen itself is a great boiler for areas where space is at a premium, or you need the flexibility of moving about valves, pump, etc. slightly. And it's pretty favoured with landlords just due to its simplicity with the control dial. There's no fancy digital panels to deal with. It is basically turning a dial for off or selecting the system temperature, and really once that's set, then it shouldn't need to be touched, and everything else would be controlled from the external controls. So the Slimgen itself comes in 4 kilowatt, 7 kilowatt, 10, 12 and 14.4 kilowatt outputs. You can get the boiler as a bare unit like this, obviously with the front cover on it, or you can get it with the components pack, which will include the auto air vent, the pump, the robo kit, a single channel programmer room stat, or if you go with the twin boiler pack, you'll get 2 zone valves, a twin channel programmer, an automatic bypass, etc. So that you've got all the right components for the install of the boiler itself. And then again, it's just the same as pipe mount a normal system. There's nothing needs done specially on the hydraulic side when we're dealing with any of the electric boilers. Now, as I says, the Slimgen itself is great due to simplicity. There's very little components to it. So I mean, with the same kind of principles as the previous boiler, we bring the main power supply in at the bottom here, comes up into the terminal block, and we'll get the good old familiar WT3, which provides your high limit thermostat for the main heat exchanger. Power then comes over through a contactor here onto the main brains of the boiler, which is a small circuit board at the side, which we refer to as the MSK board. The MSK board will then connect to the front dial and also up into the power board. Now, one of the unique features of the Slimgen boiler, as opposed to the rest of them in our range, we provide volt-free switching as well as 230 volt switching. So this is a great choice if it's replacing into an old solid fuel system where all the controls have been done 230 volt switching, and they're not really accessible to get to rearrange the wiring because of the lack of a wiring centre, etc. So by changing the dip switches on the circuit board and using the respective terminal, we can trigger this boiler using a 230 volt switch in neutral, or we can do it through the more up-to-date method of a volt-free switch, which is on the RP terminal. The pump itself is wired into the Slimgen and would generally be positioned directly below the Slimgen so that we'll get positive pressure coming up through the boiler. This allows the boiler to control the pump for pump overrun, so that when we do the shutdown, we can get the latent heat away from the elements and just get the boiler cooling down a little bit. From there, as I say, flow would normally come out the top, and then obviously you're probably going to do a bend left or right. Just to the side of the boiler, we would then expect a T-piece to be inserted with an automatic air vent, so that the air is automatically being expelled straight out the heat exchanger. Now, should the vent be shut, a manual be fitted, or no vent at all, you then risk the issues of the boiler air locking, which in general could cause damage, or it could certainly cause the WT3 to trip out and overheat. Now, as a precaution to that, we've also included up the top here what we call a water level sensor, and what that does is that checks for air. So should the top of the boiler start to fill with air, that will then shut all the boiler down and prevent it from heating, and you'll get a nice wee warning light with an exclamation mark and the power indicator on the boiler itself, showing that there's air in the system and we need to deal with that. So the quickest way around that is obviously open the vent. If it's a manual vent, change it to an automatic one and take it from there. Now, if it can be tested to see whether there is definitely air in it or whether the boiler has a fault itself. Now, by removing the red lead from the boiler's pin and touching it to earth directly, if the exclamation mark goes out, that confirms that the diagnostics side of the boiler is working. However, you definitely have air at the top of the boiler, and as I say, that will be a case of In some cases it might be a case of draining the boiler down briefly and refilling it just because of that, to get that airlock out, but if there's a vent fitted then it should escape out the vent itself. From there, your pipe will normally run down the left or right side on your flow to head out to your heating system, and if it is an S-plan system or multi-zone system, we'll then have an automatic bypass to bridge across onto the return. As I said, Slim Jims are favoured a lot with landlords, and due to the simplicity, very little goes wrong with them. And as I say, that's where they're a bit better for older systems, old solid fuel systems. You can do a quick one out, one in kind of setup. Now on the boilers, as I say, we don't have a digital display like the rest of the boilers, so fault diagnosis and operation is basic. However, we have four indicators across the front of the boiler. So the first being the power symbol. So when the boiler has mains power, you'll get a green power symbol. When the boiler gets a call for external controls, we will then see the house symbol coming on, and then once the boiler starts to heat, we'll see the radiator symbol coming on. So when the boiler's fully operational and heating, we'll have three symbols on. Should a fault happen in any one of the sensors, the exclamation mark will come on, and then a respective one of the other three LED indicators will start to do something, usually by flashing. So depending on what the circumstances and the sequence is, we can then look at the manual and that will guide you to what sensor it is. So is it a case of the exclamation mark is on and the power light is flashing, that's going to give you, put you straight up to, you've got an airlock. Let's see if there's air at the top of that boiler, or if the sensor itself's got a bit of an issue. And then you'll get a different sequence for return temperature sensor or flow temperature sensor. Now, one bit to note, especially if you're trying to run systems higher, generally we would recommend an electric boiler system to be operating between 60 and 70 degrees for a general installation. Obviously, if you're sizing your radiators for a lower delta T, which will save energy, then obviously the flow temperature is going to be lower. But generally, in a domestic, don't go any higher than 70 degrees on the flow, because really we're just starting to waste energy at that kind of level. That said, if you are trying to operate on a higher temperature, we do need to ensure that the return temperature comes back less than 70. If the boiler receives a return temperature of 70 degrees or higher, it will shut itself down for safety precautions. So similar to the, as I say, as all the other boilers, we've got the WT3, which is common, and we've also got the power board, which is up the right hand side here, to control the elements. So like the Comet Combi, there's 7 terminals on it, 3 supplying voltage in and 3 being your switching out with your neutral. So again, we can easily test whether there's voltage going to the elements, when it should and when it shouldn't, for any fault diagnosis. Other than that, with the Slim Jim, it should always be fitted in the upward position. In no way can it be put onto the horizontal. It does need to be in the upright position with the pump on the return. So, in fact, we've covered 2 boilers. I'm going to jump in and just see if anybody's got any questions with regards to the Slim Jim or on the Comet combination. So I'll give you a minute or two if you want to ask anything.
So we've got a question from Alban asking, my client is after an electric boiler. What is the best recommendation for her house to accommodate 5 radiators and a full bathroom, including a bath, a basin and a toilet?
Yep, so Alban, thanks for your question. So based on that, best boiler for the job there. We'll never size a boiler on the number of radiators. Always work off cubic volume and carry out a proper heat loss. So by all means, come back to our technical team, give us a call in with the square meterage and the ceiling height, and we'll be able to do a calculation on the phone for you, and give you a good pointers to what boiler you're going to be going down the route of. Obviously, with a bath being involved, you're going to be storing the hot water, so we could look at either the Comet combination that we've covered, or you would look at the likes of the Slim Jim with cylinder, or the next boiler we're going to go into, which is the Comet Boiler with unvented cylinder.
Okay, and then Robert asks, can the Comet be used with external controls, e.g. EvoHome, where they can have room by room control?
Yep, Robert, another great question. So all of our boilers can work with smart controls, especially the EvoHome. The EvoHome's a personal favourite of mine. If it was up to me, I'd tell you to put it on every system, because it does reduce the bills by giving the user the option of being able to control each individual wet system radiator to individual time and temperature will dramatically reduce their consumption and their bills. So if they're only using the living room during the day, only the living room is going to heat. So yeah, any smart control can be connected to the boilers. Okay, so I think that's all the questions at the moment. So let's move on and have a look at the Comet Boiler.
Introducing the Comet Electric System Boiler from EHC. Designed primarily to eliminate unnecessary external pipework and plumbing, these cost-effective, highly efficient boilers are the ideal choice for properties which have wet central heating and underfloor heating systems. To ensure maximum efficiency, all Comet boilers incorporate 6-stage heating using a stainless steel heat exchanger. This unique facility will modulate the boiler to reduce electricity consumption and running costs. The easy-to-use control panel with LED display provides operating temperatures for flow and return, system flow rate and kilowatt output information, and enables the installer to utilise the inbuilt self-diagnostic feature during installation or routine maintenance. The temperature outputs range from 25 degrees Celsius to 65 degrees Celsius for domestic hot water and 20 degrees Celsius to 85 degrees Celsius for central heating, providing a great range of temperature outputs for any dwelling. The single-phase electric system boiler outputs are 6 kilowatt, 9 kilowatt, 12 kilowatt, with the 14.4 kilowatt available for properties that require larger outputs. All Comet boilers can be installed for heating only or heating and domestic hot water purposes when used with an S-plan configuration in conjunction with our twin-channel heat pack. As well as being 100% efficient, the Comet boiler is virtually silent in operation, with inbuilt fault-finding diagnostics among its many features. It also comes with a 2-year guarantee and extended warranties are available. The Comet electric boiler from EHC, providing homeowners with complete peace of mind and optimum performance. For more information on this boiler and boiler packs from EHC, visit electric-heatingcompany.co.uk.
Hi guys, welcome back. So now we're going to have a wee look at the Comet boiler. So the Comet is our main flagship unit, which is our system boiler. The Comet itself is available in 6, 9, 12 and 14.4 single phase, and then we do 12, 14, 19, 23, 39 three phase, which can all be adjusted as well within the parameters. And then we go on to do the 48 kilowatt three phase boiler as well, which is branded under the Fusion name rather than the Comet name. But nonetheless, let's have a look at the Comet itself. So again, a lot of the components will be familiar from the last 2 boilers we spoke about. This is one of the beauties of our range of boilers. Once you get to know one and get to know how to test it and work it and how it operates, it's the same principles as we go through no matter what the boiler is, just some are a bit more basic with less components, but the components that are there are more or less the same. So with the Comet boiler, power comes in at the top, however cable entry can be made from the bottom and tie wrapped up the side onto the top connector block. Again, we're straight into the WT3 high limit thermostat for the heat exchanger. That then brings power down onto the power board, which we previously spoke about, again still with the 7 terminals controlling the elements. And then we have the main control panel in the centre here. We've got the stainless steel heat exchanger up the right hand side with a built-in automatic air vent. On the pipe collar here we've got the flow temperature sensor, and dropping down we've got a built-in automatic bypass valve. Just behind the automatic bypass valve is a digital pressure sensor similar to we found on the Comet Combi unit, and then we've got another Grundfos Erp pump, which then comes round onto the left hand side here where we've got a dual sensor. So this is our flow sensor and return temperature sensor in one, and just below that we have our 3-bar pressure relief valve, which again is discharged like a normal boiler, and we've got the inline strainer again, but as previously mentioned, we would still strongly recommend a good high quality performance filter to be fitted on the return you can never have too much filtration. The more dirt we can stop going round that system and more so getting into the boiler, the better it is for the user and the less chance of breakdowns or issues throughout the system. So touching on the flow sensor itself, the flow sensor we now use in this boiler is what's known as a vortex sensor, so there's no moving parts. Unlike older traditional sensors which were Hall effect and impeller driven, these could be affected by contamination in the system, metal particles. Because the Hall effect sensor is in essence a magnet, they clung to the impeller and then stopped the impeller. So on this boiler we changed to a vortex sensor which works in vibration, meaning there's no moving parts and there's nothing to get clogged up in it, so the failure rate of them is very, very, very low. That being said, if the temperature sensor had to fail, you will need to change the full sensor out, regardless of whether it was the temperature sensor or the flow side that failed. Now, looking up onto the control panel itself, you'll see we've got a lot more going on up here, a bit more information as opposed to what the Slimgen had. So from here we have an on-off power button. We've got the right hand arrow key which will allow you to cycle round each sensor on the boiler. As you press that, each symbol will illuminate, representing the sensor that you're currently reading, and the display will tell you what that value is. So the first time we press it, radiator will go green. That'll for us to choose the system temperature, which can be adjusted from 20 up to 85 degrees. Again, domestic dwellings, I would never recommend going above 70 degrees because we're just going to start wasting energy. As we move round, we'll then get return temperature, flow temperature, and then when we've got litres per minute, that will show us the litres per minute going through the system. Bar will give us pressure, and kilowatts will show us how many kilowatts the boiler is utilising at that exact point in time. Comet Boiler can be used for heating only, whether that is radiators, underfloor heating, warm air units, interfaces, or any other type of heat interface unit. Or it can be put onto an S-plan for the purpose of heating and hot water, or obviously the zones can be extended out further with further zone valves to provide multiple different scenarios. So it's a good flexible system boiler like these would normally be used to be a gas system boiler. All the parts are integral along with the expansion vessel. So there is an expansion vessel in the boiler which is right at the very back. It might be hard to see in the camera. So within the boiler there is a 6 litre expansion vessel. That will cover you up to about 60 to 70 litres of system water. Once we go above that, obviously it's a case of calculating out your litrage of pipework and radiators and adding on an external vessel to suit that. The great thing is you can never have too much expansion, you can only have too little. So good practice with this boiler is obviously fitting valves on your flow and return for the purpose of maintenance and service, and should you need to drain and clean out the filter or change any components rather than giving you the headache of going back and draining down the full system. So as I say, at the top we've got the automatic air vent. Now the automatic air vent itself is a serviceable part, so should water start to drip out the clear tube which is underneath and runs down the side of the boiler, that symbolises that there's debris from the heating system got into the valve body and it's stopping the valve properly closing once the air's been released. Now by all means, in most cases, you don't need to renew the auto air vent. It is a case of just unscrew it, take the vent out the boiler, run it under a tap and give it a good shake. Most of the time will clear the debris out. If it's a bit more contaminated, the top lid of it actually screws off. So using a set of grips and an adjustable, you can then unscrew the top lid, take out the plastic float and take out the spring plunger and give it a good scrub under a tap, put it back together, put it back in the boiler, and you're as good as new. Obviously for severely contaminated systems, an air vent which is got a fair few years of age on it, then we would look at obviously replacing that, and you can get them easily enough from our website or giving us a call in. So with the boilers and the Comet Boiler, every component is replaceable within the boiler, and we do hold stock on the shelves at all times. So should anything happen, give us a call in. We're happy to go through fault finding with you over the phone until you fully learn the ins and outs here, and then we can generally have the part with you within 24 hours to get that customer back up and running. So as I say, going back to the boilers, they are range rateable within the outputs that they're specified. So for instance, a 12 kilowatt boiler can be manually range rated down to 8 kilowatt or down to 4 kilowatt. Generally this feature is not used much because the boiler should be sized correctly to start with based on its normal output, and then the boiler will automatically modulate itself up and down based on the system conditions. Now those conditions are primarily the flow rate going through the boiler and the temperature differential on the system. So ideally for the electric boiler we want a temperature differential of somewhere between 10 to 15 degrees, and flow rate and balancing should be carried out during commissioning. So you want to balance the radiators like you normally would hydraulically, get even pressures and flows going through them all, but we also want to look at flow rate as well, because flow rate does affect consumption, like on any boiler, not just electric boilers. Gas is the same, but we don't notice it as much and we don't tend to focus on it. But the flow rate of the water going through the system, cycling 20 litres per minute through a 4 or 5 rad system, that system would probably work perfectly fine down at 10 or 12 litres per minute. So just bearing that in mind and being able to view the flow rate of the boiler, you can then adjust the full system down to a lower flow rate, and as I say, that just improves the modulation of the boiler and helps the energy bills off your customer in the long term. As I say, there's no set flow rate for any boiler because every system's different, especially with pipe work and bends, etc. But as a general rule of thumb, you want to, for instance, like a 12 kilowatt boiler, I would be looking to bring that down to 12 litres per minute to start with. See how all the rads are heating up, especially the furthest away one. If the furthest away one's struggling, okay, we need to bring the flow rate back up slightly on the system, and that would just be balanced out through the rads on the lock shield valves. So other than that, with the Comet, as I said, it does have an integral built-in automatic bypass valve. Now factory set to 5, so 5 is fully closed. So when you're commissioning the boiler, we do want to set that automatic bypass valve like on any boiler. Generally we want a minimum of 8 litres per minute. So when it comes to commissioning, choke off your system, bring up flow rate on the boiler screens, whatever boiler you're working on, and adjust your automatic bypass valve so you're getting somewhere around about 6 to 8 litres per minute on the bypass. Other than that, as I say, the pumps themselves are the new Grundfos smart pumps, so these modulate themselves up and down as well, and should something go wrong with the pump has got its own fault diagnostics based on the LEDs. So again, you can refer back to the installation manual for the boiler. If a red light's on the pump, it will then tell a corresponding amber light. That will then explain to what's happening with that pump. So the 3 gent faults on a pump would be red and then the last orange light on, that's the pump blocked. So if the boiler's been off all summer and not been getting used, obviously we would recommend the boiler cycled at least once a week, once a month, something like that, rather than being off for the full duration. But yeah, if the pump's been left off and it started to cavitate, then when it's fired back up, it's going to show high resistance. The pump will then stop, just to save any damage to the pump or waste of energy. In that case, there's a centre screw. Put a screwdriver in there and put positive pressure inwards and start rotating it anti-clockwise. That will allow you to spin the pump spindle, and once you feel it's loosening up, you can take the screwdriver out, put the power off, power back on, and the pump should then fire back up as normal and start running. The other 2 fault indications on the pump will be complete failure or there's a voltage issue coming into the pump, which then can be tested from the pump terminals off the panel to see whether that's true or not, or whether it is just the pump head that's playing up. So other than that, with the Comet boilers, as it says, they can be used on an S-plan. They are volt-free switching. So diagrams are in our manual. So volt-free switching is basically a no volt. It's a continuity switch. So where on the traditional S-plan you're used to your orange wire being switch live and your grey being a permanent, we now no longer link that out within the wiring centre, and you're bringing the greys and the orange cables back up to the RP terminal on the boiler, which means using the micro switch in the valve will create a volt-free switch to trigger the boiler on and off. Next to the RP terminal, we've got the NA terminal, or in some of the newer boilers it's known as the MA terminal, Master Appliance, and this is where the likes of the shower sensor would be connected that I spoke about earlier. So if there's an electric shower in the property, you'll fit a shower sensor to the cold water pipe of each shower. So if there's 3 showers, you're going to need a sensor for each shower. They'll then wire back to the boiler and connect into the NE terminal. So should the shower be used, water starts flowing through the pipe, flicks the sensor creates an open circuit, and the boiler will shut down and stop the heating elements while that's in an open circuit state. With the Comet Boiler, that's then displayed by the house symbol flashing in and out. So again, if you're called out to a boiler where the customer's got no hot water, isn't getting heating, the boiler's not operating, if you get there and the house symbol's flashing, first thing to do is check the NA terminal. Is there wires connected to it? Right, okay, so there's some type of master appliance being connected to that to block the boiler. So it would be a case of going to find, and is it a shower or is it a control circuit off another high load appliance, as I mentioned, a cooker or a pottery kiln or something along those kind of lines. Obviously if it's a shower sensor and the shower's not in use, the sensor's jammed, it would be a case of trying to free up the sensor, or at worst case replace it if it's completely failed. So if a master appliance has not been used, then we leave the factory link in the terminal so that the boiler's going to only operate off the external controls on the RP. Now, like the Comet Combi and any of the boilers on the Volt Free, all of them can use smart controls. So whether you want to use the Hive, the Nest, the Honeywell Evo Home, or any other of the equivalents that are out there now, they can all be utilised with the systems. With the fault diagnostics on the Comet Boiler, again, it's a bit like Slim Jim, it gives flashing indicators depending on the fault, albeit there's more indicators so it can be more precise to the fault. So for instance, if we get a flashing F symbol, that's going to tell us that the flow temperature sensor, which is NTC, has failed, and you're going to be replacing the sensor. Again, same with the R. If the R symbol starts flashing, return temperature sensor has failed. The P, which most people associate with pump, is really actually symbolising flow. So when flow is experienced in the boiler and it's above the minimum threshold of 5 litres per minute, P light will be solid and then allow the elements to kick in. If the P light is flashing, then that tells us that there's insufficient flow rate going through the boiler. First thing you would be checking would be the internal filter and the external filter, as they're going to be the more common aspect of why there's no flow. We can then go on to check the pump and make sure that the pump is okay. If the pump's fine, then it's most likely that you've got a blockage further out onto the system. As I say, it's very rare for the flow sensor to fail, so that would be the last thing we would generally look at should it be a flow issue. However, not to say never, as the systems do get older, the sensor may well be the answer, but as I say, I would always treat the sensor as the last option. Always go and investigate the rest of it, see if the actual system is flowing and you've got flow out through your radiators, etc. Moving on, as I said, if the house symbol is flashing, your master appliance has interrupted due to it being active. If the house symbol is solid, we've got a call for heat from the external controls. If the bar indicator is flashing, then that's symbolising that there's insufficient pressure within the system, and hopefully it should just be needing a top up. Worst case, if the sensor is reading 00, but you're confident there is pressure in the system, it's most likely that the pressure sensor is clogged up with dirt. To save a bit of money, the sensor can be removed, and with a paper clip, inside the sensor itself is a small hole. When you look at that, you'll find that small hole's been blocked up by a bit of carbonite or something like that from the system. Using a paper clip, you can pick away what's there and then push the paper clip right into the sensor as far as it will go. And 9 out of 10 times when you fit that back onto the boiler, that sensor will be back up and running for another good long period. If it's too badly contaminated, then obviously it would be a new sensor, or if the sensor itself is displaying 2 dashed lines on the screen, we would need to look at replacing the sensor, because that tells us the sensor's failed outright. Again, we can move on and check the kilowatts on this boiler, so we can see exactly how many kilowatts the boiler's using at that precise moment in time, and whether the boiler's modulating. Obviously, when the boiler starts up, it will do a soft start, so it will build itself up to the maximum capacity. It will then run at the maximum capacity until the system temperature rises, Once we start to hit the target temperature, that's when the boiler starts to work out how well it can modulate down based on the parameters we discussed, and then you'll see it to falling back down to where it can deem as a happy medium to keep that system going. So other than that, that's the main points of the Comet Boiler. Again, it's very easy to work on, as I say, with the display panel coming up the faults, and there's very few components which are all available. But as I say, should you have issues with it, we're always on the end of the phone and happy to help you. So we're now going to move on to our combination boilers, which will be a bit more familiar for the gas engineers that are out there. And the first one we're going to cover is the Astro.
Introducing the Fusion Astro electric combination boiler from EHC, a cost-effective alternative to electric storage heating, oil, solid fuel or LPG systems. The Fusion Astro electric combination boiler is the perfect solution for properties with no access to mains gas supply and homes which have gas boiler restrictions. The boiler is perfect for wet central heating and also ideally suited for homes with underfloor heating. The electric boiler outputs are 12 kilowatt and 14.4 kilowatt single phase, and 18 kilowatt and 24 kilowatt three-phase. The operating temperatures of the boiler can be adjusted using the easy-to-use control panel, which boasts an LED display. The temperature outputs range from 30 degrees Celsius to 60 degrees Celsius for domestic hot water, and 30 degrees Celsius to 80 degrees Celsius for central heating. Among its design features, the Fusion Astro is 100% efficient, with a compact design, low running noise, rapid heat-up times, and a fully modulating control system. It also has inbuilt fault-finding diagnostics and ensures safe operation with a robust, fully insulated heat exchanger. The Fusion Astro electric combi boiler provides on-demand instantaneous domestic hot water. They are suitable for small properties that have a shower and hot water outlets for sinks. In homes with larger hot water requirements, it can be combined with a hot water storage cylinder via an S-plan configuration. The Fusion Astro Combi Boiler comes with a 2-year guarantee and provides homeowners with complete peace of mind, reliability, performance and safety. For more information about this boiler from EHC, visit electric-heatingcompany.co.uk.
Alright, welcome back. So hopefully you enjoyed that short video on the Astro. So as it's said in the video, the Astro is the first of our instantaneous wall-hung combi boilers that we've brought to the range. So with the wall-hung combination boilers, this is where, for those in the gas trade and that, brings a bit more familiarity into it, and away from the electric side. As much as it's still an electric boiler, it's now a combi. So same principles. Obviously on the bottom of the boiler you've got your flow and return for central heating, you've got your cold in, your hot out and your free bar PRV discharge. Now with the Astro's a nice basic and robust combination unit, which is available in 12 kilowatt and 14 kilowatt single phase, and then 18 kilowatt and 24 kilowatt three phase. Now with the combi boilers, this is where a bit more restriction and caution comes in when it comes to sizing it, because going back to the power supply, we are limited on power supply in domestic dwellings to a maximum of 100 amp. Some properties may be lower, especially flats, they could only be 60 amp. Now the minimum size of capacity of instantaneous combi is 12 kilowatts. That's going to see a hot water flow rate of about 4.5 to 5 litres per minute at a 30-degree rise. When we move up to the 14.4 kilowatt, we're going to see flow rates of around about 5.5 to 6 litres per minute. Again at the 30-degree rise, which is a lot less than what you would see on a gas combi. Obviously off the likes of a 32 kilowatt, which is going to achieve 13-14 litres per minute. So for those kind of flow rates, we then need to go into the three phase, which would be the 18 kilowatt, which will operate about 9 litres per minute, and the 24 kilowatt will give you about 11 litres per minute. Now it's the same, flow rate is the same no matter what energy source. For every litre per minute you need a certain amount of kilowatts behind it. So that's where 5 litres per minute on a 12 does sound low compared to what you're used to in the gas, but unfortunately with electric, as I say, we are limited, whereas with gas you could throw any size of gas boiler in. One bed flat, you throw a 32 kilowatt in to achieve 12-13 litres per minute, but it's dramatically oversized on the central heating and wasting a lot of energy. So with the electric boilers being limited on power supply, we're going to see lower flow rates. Now, because of that, 12 and 14 kilowatt boilers are ideal for 1-2 bed flats and 2-bed house where it's only got kitchen sink, bathroom sink and a standard mixer shower that will operate at 5 litres per minute. You'll be perfectly fine. However, they will not fill a bath, and we certainly don't recommend it. Building standards says that a minimum boiler capacity of 18 kilowatts is required when filling a bath off on instantaneous water. So as I say, 12 and 14 Combi boilers, shower and sinks, fine. If it's a bath, we need to fall back to the likes of the Comet, Slimgen, or any one of the boilers, which can then be coupled up to a hot water cylinder so that we can store that water, and which doesn't take as much electrical loading. Obviously for properties with 3-phase, we can go into the 18 and the 24, and you're going to see the same flow rates as you would gas 24 kilowatt boiler is about 11 litres per minute. The electric 24 kilowatt is going to give you 11 litres per minute. So these can handle baths, they can handle showers, etc. Now the Astro itself looks more like a traditional gas combi boiler, especially from the midsection down the way. The plate heat exchanger, the manifold set, the diverter valve set and the pump block are used, it's the same setup as used in quite a lot of the leading brands of gas boiler out there. So when you're looking in the boiler, it will look familiar, it operates in the same way. The only difference is the top half, rather than having a large gas burner and heat exchanger up there, we've got a chamber with electric elements, we've got a bit of control board in there, and we've got an RCD at the top of the boiler. So the Astro itself, basically in the start, that power comes in at the top, drops down into an integral RCD, which is used for internal fault issues. So where on the other boilers we've got the WT3 for high limit thermostats and over temperature, on this boiler we use an RCD which is linked up to an overheat thermostat. Should that go into overheat, it will trip the RCD out and take all the power out to the boiler. So dropping down from the RCD, we've got a cooling fan. Behind the cooling fan is a relay control board which controls the elements on and off via relay with this boiler. Moving down the boiler, on the heat exchanger, we've got 3 sensors on the heat exchanger. We've got a high limit thermostat, we've then got a high limit short circuit thermostat. So this is the one that should the primary high limit stat fail and it goes into full overheat, it will then trip the RCD out. Below that is our NTC sensor for central heating. And at the top of the heat exchanger, just where this blue cable is, we've got a water level sensor, so that's a float sensor. So again, should there be air in the void at the top of the heat exchanger, we'll get a H code up to demonstrate air and heat exchanger. And should that happen, we'll get a manual air vent. It's a case of unscrew the manual air vent, air will emit out as soon as water's visible. Obviously close the valve off, and the fault code will have went away again. Now depending on the amount of air that's come out, it might then show up a different fault code which will symbolise that there's insufficient water pressure in the system. So down the bottom left bottom corner here, we've got a manometer mechanical pressure gauge, so you can quickly top it back up to a 1.5 bar pre-fill. So moving down the heat exchanger, the elements are all positioned on the bottom of the heat exchanger facing upwards, and these ones can be replaced and extracted individually. Dropping down into the bottom end of the boiler, as I say, the bottom end is more familiar, as it's the same setup as we're using and it's been used in a lot of gas boilers previously. So on the return side here, we've got a Willow smart pump with pump block with automatic air vent. Just behind the pump is your 3-bar PRV blow off. We then move round onto the manifold set with the flow sensor on the cold water inlet onto the plate heat exchanger. And now the flow sensor itself is a digital type electronic flow sensor, where there is also a cartridge inside with a gauze filter on the cold water inlet. So should there be a blockage or restricted water coming through the boiler, you can remove that out, check the gauze and give it a clean. Moving over to the left hand side, we have the flow manifold, which has the diverter valve to swap between central heating and hot water. And on that manifold we've also got an electronic pressure sensor. Should the pressure drop, the boiler can automatically notify the user by displaying the fault code on the screen for no pressure. And we've also got the hot water NTC sensor down on that manifold as well. So should any one of the sensors fail, you'll get a code starting with a H, and it will be between H1 to H6. And within the manual we've got a nice wee table that tells you what each of those numbers represent, so that we can quickly diagnose and rectify it. Now moving down onto the control panel, we've got two dials on the control panel with an LCD display. The left hand dial will operate the hot water temperature, and the right hand dial will set the boiler between off, hot water only, or give you the central heating temperature. So simply by turning them, you will then get the temperature of that dial coming up on the screen. It will then revert back to the current temperature being read by that sensor. So we can set the hot water, we can then set the central heating, or you can turn the central heating off and just have it in hot water mode. On the side of the screen is two symbols, which is a radiator and a tap. Depending on what mode the boiler is in at that time, you'll get a small dashed line to the side of the left side of the screen, just to represent what mode the boiler's in at that point in time. Now for external controls on the Astro, there is a terminal just at the top of the boiler next to the RCD with a factory link in it. So during install it would be a case of removing the factory link. Again, these are volt free connections, so please don't apply 230 volt or the likes to it. They are volt free continuity. So remove the link and connect on your external controls. So obviously we provide a range of external controls suitable for it, or again if the customer's wanting smart stats etc, any one of them can be added onto the system for the central heating side. So with the Astro, as I says, flow rate is the big thing when commissioning. So on the cold water inlet of the boiler, you do want to fit a stopcock, so that when it comes to commissioning, you're going to want to turn the hot water tap in the kitchen sink on at full bore, and then using a flow cup measure the flow rate coming through that tap, and come back to the boiler and restrict that down using the stopcock you've fitted, so that it's limited to the requirements for that boiler. So as I say, for a 12 kilowatt boiler, we want to limit that to 5 litres per minute. For the 14 kilowatt, we want to limit it to 6 litres. The 18 will be limited to 9, and the 24 would be limited to 11. Because once we go above that, all you're going to do is get a call back from the customer if it's left running too hot, that the water is tepid and is not getting to temperature. So by limiting that, it keeps the boiler within its parameters. Obviously on colder days, the customer would need to be educated that on colder days, to get the water hotter, they're going to need to manually slow the outlet down themselves, just so that the water's passing through the boiler a bit slower, can pick up a bit more heat and get a bigger rise on the temperature. But other than that, it is a basic and good functioning boiler. So with the Astro boiler, as much as it is a Combi boiler, instantaneous, there is nothing to stop you doing a hybrid setup where the boiler is in and also has a cylinder in the property as well on an S-plan with zone valves. So obviously certain outlets, possibly some sinks, could be supplied by the instantaneous side of the boiler, whereas if the property had a bath, the cylinder could supply the bath, or the likes of a rain head shower, because where the boiler can cope at 5 litres per minute with a standard thermostatic mixer, a rain head shower generally needs in the region of about 20 litres per minute to operate sufficiently. So again, the boiler's not a 12 or a 14 is not going to cope with a rain head shower. But as I say, there's nothing to stop a hybrid setup going in. It is a bit more work, so I mean in general, really you would be going down a system boiler and cylinder, but if there is a need there, there's nothing to stop a hybrid setup with a cylinder going in purely just to do the bath or the shower to whatever's the nature of the customer's requirements are. So what we'll do is we'll now move on to the Mercury, which is our other wall-hung instantaneous combi boiler, and we'll have a look at that one.
Introducing the Mercury Electric Combi Boiler from EHC, the electric boiler solution for the future of heating and hot water, with the added benefit of weather compensation and advanced service diagnostics. The Mercury Combi Boiler provides a cost-effective alternative to electric storage heating, oil, solid fuel or LPG systems. It's the perfect solution for properties with no access to mains gas and homes which have gas boiler restrictions. It's also ideally suited for both wet central heating or underfloor heating. The Mercury Combi Boiler brings a new dimension to the electric combi boiler market with the introduction of external weather compensation. This feature helps reduce energy consumption by automatically adjusting boiler temperature based on outside temperature. The Mercury Combi Boiler outputs are 12 kilowatt and 14.4 kilowatt single phase and 19 kilowatt and 26 kilowatt three-phase. The operating temperatures of the boiler can be adjusted with the easy-to-use digital control panel, with adjustable temperature outputs ranging from 30 to 60 degrees Celsius for hot water and 20 to 85 degrees Celsius for central heating. Among its design features, the Mercury Electric Combi Boiler is 100% efficient with a compact design, automatic power modulation, rapid heat-up times and low system pressure warning. The Mercury Combi Boiler provides on-demand instantaneous domestic hot water, making them suitable for small properties that have a shower and hot water outlets for sinks. It also features bare wire heating element technology for domestic hot water. These elements are more robust in tackling the formation of limescale, especially in hard water areas, as they operate at higher temperatures with a lower surface area. The Mercury Combi Boiler comes with a 5-year guarantee and provides homeowners with complete peace of mind for reliability, performance and safety. For more information about this boiler from EHC, visit electric-heatingcompany.co.uk.
Welcome back. So we're now on to our last boiler in the range, which is the Mercury. This is the latest boiler to come onto our product portfolio. And again, this is a wall-hung instantaneous combi. However, as you'll have seen from the product video, it works a bit differently as to the Astro and how a normal traditional combi boiler would operate. We don't use the plate heat exchanger with manifolds and diverter valves. With this boiler, we've got two separate systems within the one unit. So the Mercury, again, this boiler is provided in 12 and 14.4 kilowatt single phase, whereas on the three phase it is a 19 kilowatt and 26 kilowatt. Now, with the way that this boiler operates in hot water mode, we get slightly better hot water production than that of the Astro or any other electric combi that uses plate heat exchanger, etc. And that is due to utilising bare wire element technology for heating the instantaneous water. So from that, the 12 kilowatt on this on the Mercury will actually give us closer to 6 litres per minute, whereas the 14.4 will give us in the region of 7 litres per minute. And then once we go up to the likes of the 19, we're pushing between 9 and 10 litres per minute, and then for the 26 you're going to get round about the 12 litre per minute mark. So again, looking at the boiler itself, it's very compact and very light. So your normal gas combi and certainly the Astro combi, your boiler weights are up in the 35, sometimes even close to 40 kilo mark. This combi weighs in at 19 kilo, so there's a wall plate, gets bolted on, and then it's a case of quick lift and drop the boiler onto the hooks, which means it's an easy lift for any engineer on their own. Now, the boiler itself, as I say, some of the key features of this boiler is on the hot water side, where it's the bare wire element technology. Now, this provides two key features. One, it provides a bit better flow rate because we're putting more energy directly into the water rather than losing it through the transfer across a plate. But secondly, because of the wires are so thin and they operate at such high temperature, they're less susceptible to limescale. So rather than limescale cling to an element like a normal traditional element, because of the high temperatures, it actually vaporises the limescale. So hard water areas, this is the better choice on the electric instantaneous combis throughout the market. Other great features to this boiler is the external weather compensation, bit like the Comet Combi we looked at. That can be set up so that the boiler can measure the outside temperature and automatically modulate the internal temperature of the primary system based on the outside temperature, helping to keep those energy bills down to a minimum for the user. But again, not all users understand external weather compensation or like the idea that one day the radiator might be at 50 degrees and the next day it might be at 70 degrees. They like to know it's a constant. So the external weather compensator can be deactivated, but we would always recommend it as much as possible just to keep those bills down, especially with the fact of price of electricity at the moment. So looking at the boiler itself, main cable connections are up in at the top right hand side, and we drop over onto a traditional WT3. Now with the Mercury, one key point I like to make is if we draw a line down the centre of the boiler, everything to the left hand side is to do with the primary side, the central heating side. Everything to the right hand side is to do with hot water. So when we come down the boiler, we've got a WT3 here which will do the central heating. So should the primary heat exchanger for central heating overheat and trip out, this WT3 will go. Now if this one goes, all power will be lost to the boiler. However, on the hot water side, the hot water's got its own WT3, so should the hot water heat exchanger overheat, power will still remain on to the boiler and the boiler will still be able to produce central heating, but it's only the hot water that's affected. So obviously if you're going out and customer, I've got no hot water, first thing you can do is check the brass pin in the middle, push it in to reset it. Now it does take a good bit of force to push them in, so don't be gentle. And that will then bring the power back on. Obviously that's generally tripped out due to too little a flow rate, or it could have been, as we've said previously, the power's been switched off while it was in hot water mode. So moving down the right hand side, we have the main control circuitry for the hot water side controlling the elements. The elements are encased in a plastic heat exchanger due to the bare wire technology. And below that we have a flow sensor. So that obviously when the hot water tap's open, the boiler will fire up into hot water mode based on the flow sensor getting a reading. We then have two temperature sensors in the bottom of the heat exchanger for cold water in and hot water out temperatures. When we move back up to top and onto the left hand side of the boiler, as we've said, we've got the WT3 for central heating. We've then got the same familiar heat exchanger with automatic air vent at the top. And on the collar we've got the flow temperature sensor, which is again is an NTC sensor. Moving down, we've got the main control panel. So from the main control panel we can control the central heating and the hot water side. So we can view all the sensors live data for the hot water side, and we can view all the sensors live data for the central heating side. The power board, which with the triax for controlling the elements, which again we've seen on the other boilers, is tucked in to the back of the control panel, but again it's the same as what we've looked at prior. Below this is a smart Grundfos smart pump, and below the pump is the digital pressure sensor, which again we're using on the other boilers. Now below the heat exchanger on the return pipe we have a NTC sensor and our 3-bar pressure discharge. Again is discharged as normal. Now this pump itself, on this boiler you'll notice we don't have a flow sensor like we spoke about on the Comet. So the pump itself measures flow, so we've got one less component to worry about. The pump deals with the circulation and it also deals with providing the information back to the control panel to what the flow rate is in the system, so that again we can balance the system and see how healthy it's operating. Now with the control panel itself, again like the Comet, we're using the right hand arrow key, and that will cycle through each indicator on the panel to provide you the live data from that respective sensor. So when you first press it, it will go to the tap symbol, and then it will allow you to adjust the hot water temperature range, and then after you go after that, the tap will stay on and it will go around each indicator thereafter and that will be showing the respective indicator for the hot water side, so flow temperature, flow out, cold in temperature, and flow rate going through that hot water heat exchanger. It'll then move on to the radiator symbol, and if it'll move on to the radiator symbol. If the external weather compensator is not fitted, then it'll allow you to adjust the temperature up and down for obviously central heating system. Otherwise, if the weather compensation is active, then there'll be no change available to the system operating temperature, as the boiler's going to do it automatically. But again, we'll then cycle through and we'll get the flow temperature, the return temperature, we'll then see the flow rate, etc., the bar pressure, and we'll move on and see how many kilowatts the boiler's using at that point in time. So again, similar to the Comet, should a fault happen on any one of these sensors, we're going to see the respective light coming on, whether that is central heating or hot water, and then the sensor responsible for the fault will be in a flash-in mode, so that we can quickly navigate through the system and see whether it is indeed failed. Again, if it's failed completely, it will be showing 2 dashed lines. Now, when it comes to the external controls for the central heating side, again, connections are made on the bottom of the panel on the RP terminal, and it can be used with smart stats or any volt-free controls to what the customer chooses. And we've got the NA terminal for the purpose of the shower sensor or any other master appliance blocking circuit that we're going to drop in there. We've got an extra terminal here, which is going to be for your external weather compensation sensor. Now, if you choose, or the customer does not want the external weather compensation, it's just a case of simply getting into the engineer's settings on the boiler's panel, which is a case of turning the boiler panel off, press and hold the right hand arrow key, and then press and release the power button. That will drop you into the engineer's menu, and from there you can go in and change a couple of different settings always. Be careful of what you're changing, but the main one will be the weather compensation, so you can set the coefficient curve of the compensator, or you can put it to 0, which will deactivate the sensor completely. So other than that, with the Mercury, as I say, it's a great boiler. Similar to the Astro, you do want to limit your flow rates, but with the Mercury it's a lot easier. You don't need your flow cup anymore. So again, on the cold water in, you're going to have a stopcock, and then from there go to your hot water tap in the kitchen, fully open it, but now rather than running back and forward with the flow cup, with the tap fully open, we can come to the boiler, cycle through the panel to hot water flow rate, and then just adjust down your stopcock until you get the respective value on the screen. So again, as I say, 12 kilowatt you'd be looking at 6 litres, 14 kilowatt you'd be looking at 7. Now, same as the Astro or any Combi boiler, instantaneous one, if the 12 or the 14 is used, again, that's not suitable for baths because of the flow rate. So please, obviously, if it is a bath or a high performance shower, rain head, etc., you're going to need to use a boiler cylinder rather than an instantaneous unit. But for standard mixer showers, then these are going to be a great choice for 1 and 2 bed flats that don't have the space for cylinder capacity. But as I said, it's just bearing in mind, as I say, is that the main key point is power supply as well. Just make sure that you're checking that incoming power supply to verify that you do have enough power to be able to run the property and the boiler itself. As I say, any one of the Combi boilers, you're going to need to straight away make sure you've got 100 amp coming in that service cut out fuse. So from that, as I say, it's a really good boiler, easy to install, and you're getting great feedback from the display panel with the advanced diagnostics. So as I say, that's us kind of covered all the main boilers on the range. We also offer a setup where we can replace gas and electric warm air systems, and that's using the Comet Boiler along with a water to air heat exchanger unit. So if you are up in front of any customers who've got a gas warm air unit and it can't be replaced due to limitations of fluing, especially sea ducts, etc., or it's a customer with an electric warm air unit which you now no longer get spares for, we've got an option to remove any one of them and drop an electric boiler with a blower unit straight back onto the plenum that the old one sat on, and continue to blow heat out through that existing ductwork to save any upheaval throughout the rest of the property by trying to run cables or pipes. So by all means, if you do come across properties like that, give us a call. We'll happily assist with it and give you guidance to how best to replace that. But the replacement is extremely easy. It's a case of boiler on the wall, blower on the floor, and 2 pipes to link the 2 units together. So as I say, just a quick recap across the products. I mean, the key features to take away from this when doing electric is always check the property power supply coming in and make sure you've got enough, and also sizing of the boiler. Do a proper heat loss calc. It doesn't have to be right down to the U values, but a proper heat loss calc so that we're getting the boiler as close to the requirement as possible. As it says, don't be shy phoning in. If you're unsure, as long as you phone us in with the square meterage, the ceiling height, we'll do the calc for you and point you in the right direction of the product that you need, so that we know that the customer is getting what's properly suitable for that property. We'll call it a day there. Obviously, thank you very much for attending our first course. Obviously, keep an eye on the training academy. We will be uploading more videos, how-to videos, and some fault finding videos as the months go on, and we'll look to run some more of these training webinars as time goes on as well. So as I say, create yourselves an account and just keep an eye on it. In the meantime, the YouTube channel as well has got a lot of videos which have been put up over the years which are worth a watch. But as I say, some of the newer videos and more so some fault finding for the engineer itself. We're going to be doing a stream of videos focusing on individual faults, how to test them and how to repair them in a bit more detail, rather than cramming it all into today's webinar. So if that's everyone okay at that, as I say, wish you all a good day and take care.